So preparing for the build, preparing the host system. So we need to get the host system, which, as I say, in this case is Debian 13. We need to prepare it to be ready to build Linux from scratch. And the first thing we need to check is to ensure that the versions of the packages that the host system has got A exist, and B that they're at least a minimum version to allow Linux from scratch to build successfully. So these are the packages that we need as a minimum and the version numbers. And here is a script that the Linux from scratch team have provided us to allow us to check, make it a lot easier for us to check. So if we copy that by highlighting it. Now normally if you highlight in Linux and center click on the mouse, it will paste what's been highlighted. This mouse button is a bit funny. It needs quite a lot of pressure to press, so I might not be actually using that a lot. I might just be using the standard cut and paste. Luckily it did work there. And you can see straight away I've pasted that in and it's come up with a lot of errors. So if I rerun that, because when I've pasted that the screen's sort of got messed up a bit, so I'll clear the screen and I'll rerun that again. Bash, see it's created that text I pasted in has created this script. So if I rerun that, you can see it a bit clearly now that we've got some errors. It couldn't find Bison, Gawk, M4, text info, and there's some links that don't exist either. So we need to resolve that. So I'm just going to get some notes out that I've made a few years ago about this, because I forgot all about this. I haven't done any preparation for this other than getting the host machine ready. So I'll be doing a lot of stuff off the top of my head and cribbing from previous notes I've got, so bear with me while I dig those notes out. Okay, so what we can do with some of these, I believe, is we can install a package on Debian and Debian-like operating systems such as Ubuntu. You can install something called Build Essential. So let's look at that first of all. So I'm going to become, let's see if I've got sudo access. I have I? No, I haven't. So I'll become the root. And I'll do apt install. Now if we install something called Build Essential, this package installs a lot of, oh, it's already installed, okay. So we don't need to do anything that. So the other packages that aren't there need to be installed manually. So let's try doing that. Let's go back to root and do apt install Bison, Gawk, and text info. Let's see what happens with that. Oh, and M4, just noticed there as well. So Gawk, M4. So what does it say? Okay, so it says installing Bison, Gawk, M4, text info. Okay, that's good then. So let's press enter there to fetch those. Wait for those to install. lost my notes now. Okay, so that's completed. So if I come back here and rerun that script, let's see what it says now. So all the errors have gone bar one. We've got all the packages installed, and we've got two of the links now installed. Awk is GNU Awk and Yak is pointing at Bison. The only thing is that the shell is not bash. So let's try running sh minus version, see what it says. Okay, looks like whatever it is doesn't recognize. Exit, so we're not quit. Let's see if the shell environment variable set. Well, it says it's set to bin bash, but sh is not pointing at that. So let's have a look at. See if there's a. Okay, so that's the problem. As you can see, although we've got bash installed, the sh symlink is not pointing at bash. It's pointing at something called dash. So we need to fix that. So what I need to do is to go back to root again, change into the bin directory, and we need to overwrite that symlink. Let's just look at it again. ls-l sh. You can see it's pointing at dash there. So what I need to do is to overwrite that. So create another symlink -s. I want to see what's happening, and I want to force overwrite that link, that symlink, with bash to point to sh. And you can see it's responded saying sh now points at bash. And I can confirm that with listing sh, long listing sh. You can see now sh points to bash rather than dash. So if I come back to the Kernotex user, recall our command for running the script, and you can see everything is okay now. We've got rid of all the errors. So we've installed the four packages that were missing, and we've also redirected the symlink sh to point to bash rather than the dash command it was pointing at before. So that now passes. Let's move on to the next part. So again, we've got some information here about the different chapters and what they cover. It says the first 4 chapters must be run as root. The next couple of chapters, 5 and 6, will be run as an LFS user. The partition where we're installing the new LFS system must also be mounted. And there's some general compilation instructions which we'll come to, I believe, which are critical to follow those to ensure a successful build. And again, chapters 7 to 10, obviously the LFS partition must be mounted, because this is where we're going to build the final tools and the real LFS system. So the next thing we'll do is to create a new partition. So there's nothing specific here on how to do this. It just gives you some information, and it's basically because there are numerous ways you could do this. So what I'll do is I'll just show you how I'm going to be doing it. The grub BIOS partition, this machine hasn't got UEFI at all, so I won't be creating a GPT partition table. If you're using some modern machine, you probably do want to be using GPT, and if you don't want to use UEFI, you'll have to probably set your BIOS to use the compatibility layer so that it can boot from a BIOS enabled operating system. Otherwise, if you do want to use UEFI, it's mandatory to use a GPT partition table, and you'll have to follow some of the instructions in the BLFS page to install extra packages for UEFI. I haven't gone through that in the previous video, but I have done it in one of the other version 12 Linux from Scratch videos that I've done. I can't remember which one, but certainly if you look at 12.0.1.2, I'm pretty sure I've done one of them with UEFI boot. I don't think I did it in the previous boot, in the previous version 12.3. But you'll see how I've done that. I certainly have done it in previous versions. If you just search for my videos with UEFI, you'll find something. The reason I try and keep away from the UEFI is because it just adds more complexity in the same way as I keep away from systemd. It just adds more complexity to the build. But if you are interested in learning those, then again, I've done videos on systemd before. But as I say, I won't be doing it this time. It's just going to be a basic systemv installation with a BIOS boot, because this machine has only got the BIOS boot. It suggests what partitions to install there. I generally install a separate boot partition. It just keeps the kernel, but basically the boot files separate from the main system. If the main system ever gets trashed for some reason, the boot partition is separate. It's less likely to be trashed as well. And also, as it does say there, on some older systems that might not be able to access larger disks, it's also another way of getting around that problem. So, for example, if you're on a say 486 machine, which can't access a disk greater than 8 gigabytes, then by having a separate partition, the BIOS would be able to access that smaller partition, and then the code within the boot, the kernel boot, takes over, and it is allowed, or it is capable of accessing partitions across the 8 gigabyte boundary, or even if there's any other boundaries, such as I think there was a 512 megabyte boundary at one time as well. So yeah, I normally tend to do that. It makes the configuration slightly more complicated, but not too onerous. Then we'll have a swap partition as well, and the main root partition. So let's do that, because the next bit is all about creating the file system. So I'll become root again. So you can see I've got 2 hard disks in here. Hard disk that we've booted from SDA is a mechanical disk, and you can see there's the layout of it. We've got a main root partition, which incidentally has also got the boot partition, or the boot directory in it, with all the kernels files. And then we've got a second partition, which is an extended partition by the looks of it. No, sorry, I'm not sure what that's for, but it's oh yes, I think that's an extended partition. It's a container for the swap file, which is on the extended partition. So that's all that's on there. So, and we've got the SSD where we're going to be installing Linux from scratch, which has got nothing on it. It's brand spanking new. So if we do fdisk / what I would normally recommend is to copy and paste these designations, just so you don't make any typos and format or delete the wrong disk. So let's do a P to print. There's nothing there, but it's created a disk label for us of type DOS by default. So let's create a new partition, create a primary, start the first sector, and I'm going to create a partition that's, say, 500 megabytes. Should be big enough for this kernel that we create for this build, and any other ones we might want to create in the future. And you can see it's created a partition type 1 of type Linux, which is good. Create another partition, which is going to be our main root partition. And the last sector, well, I want to create a swap partition as well, a small swap partition, and I want it to be a gig, so I'm going to do a minus there. Normally I'd do plus, say, 1 GB to create a 1 GB partition, but I want to reserve 1 GB at the end of the disk for the swap partition. So by putting in -1 GB, it will use all the space apart from the last gigabyte in the partition. So you can see now I've got a root partition that's approximately 117 GB. And then finally, I'm going to create a swap partition 3, which as you can see is 1 GB because that's what I reserved when I created the previous partition 2. But I need to change the type of that partition because I want it to be a swap. So I'll just change the indicator of partition 3. If you do L, it will list all the different partition types. I want to create a swap partition type, so it's 82 I need to type in here. In fact, there's some of the more common partition types you might want to use. And you can see it's changed to Linux swap. If I just print up the table, you can see I've got a boot partition that's 0.5 GB. The main bulk of the disk is taken up with what will be the root partition, and then I've reserved or allocated 1 GB to a swap partition. So if I just type W to write that table, you can see that's now been written to the disk. In fact, if I do fdisk -L, you can see again, there it is. So now I need to create some file systems on these partitions. So first of all, I'll format the boot partition, which is that one there, and that's done. And now I'll do the main root partition, which will take a little bit longer because it's bigger, a lot bigger. Okay, that's done. And now we're going to create the swap. Right, I've just changed mouse, so yeah, this one's a little bit slower. This one's got a bit of a better center button for clicking. I'll just change the speed of it. Right, I think that's okay. Let's try a little bit faster. Oh, I've been changing the wrong one, just realised. Right, that's better. I wonder why it wasn't improving every time I made a change. Right, still quite slow. Oh, that's scrolling speed. Right, that's a bit better. Okay. Right, so sorry about that. Let's do the swap partition now. So mk swap, just scroll back up, and our swap is dev sdb3, and that's done. So now we're going to export a variable called LFS, which will point to the location where the LFS partition will be. So that will, or should always exist. So if we view it, you can see it's set. We set the UMask in case the host distro has got something different. Let's just see what it has got. It looks like, yeah, it is different. So let's set that now. And that means that the permissions on any files and directories will be correct for Linux from scratch. And as it says here, I've already been checking this anyway, but it says here to check with echo$lfs to check that's been set correctly. And as you've seen already, do umask to check that the setting that we set to 22 is correct. And as you saw, the original one was 2, which was incorrect. And as it says here, you can set these into the bash profile if you wish, so that they're always there when you log in. I probably won't be doing that because I'll probably be doing this in one session, but you can do that if you're planning on shutting down and restarting over time. So the next thing we're going to do is to create the actual mount point where we're going to put the partition for the Linux from scratch system. Now we're going to mount it, so let's copy that in there, and if you remember, it was SDB1. Sorry, SDB2 was our root partition. This is the root partition we're mounting. There it is. So if we do df-h, you can see that at the LFS location we've got 110 gigabytes free. Linux from scratch system probably needs about between 10 and 16 gigabytes by default. If you've got other systems, you can mount them now. So we could, for example, create the boot directory within the Linux from scratch system and mount that as well. So that's SDB1, mount that at boot, and you can see there we've got oh yeah, I've done that wrong. That command should be SDB1. That's better. Yeah, that's better. Now we've got the boot partition, which is only, well, 430 megabytes after the file system's been installed. But you can see it's by far the smaller of the two, so that's the correct layout. The larger of the two partitions is the root, which is at MNT LFS, and the smaller of the two is the boot partition, which is MNT LFS boot. Now it recommends to change the ownership of that directory to the root. It should be that already, but just to ensure everything's consistent with the LFS instructions, we'll do that. Change the access, the permissions to 755. So if we look at that now, we can see that the ownership of that directory is root, owned by root, user and group, and the permissions are indeed 755. So the 7 is those 3 permissions there, and 55 is these 2 here with RX. And finally, we'll turn on the swap partition, which is /dev/sdb3, the third partition we created, and you can see that's been activated correctly. And we can just confirm that by typing in swap on. And you can see that actually the system has already got a partition. Obviously we saw that's been activated with a higher priority. What I might do is turn that off, the one we've just created, or activated rather, and reactivate it with a higher priority. We can do that with the -P give it a priority of 1. And if we now do swap on, you'll see that STB3, which is the partition on the SSD, has got higher priority than the system swap, so it's going to be used in preference, and it's going to be slightly faster because it's on an SSD.